Howdy and welcome back. So let's begin with the motivation and introduction to function templates. So just some motivation here. C++ requires us to declare variables and functions using specific types. However, a lot of code is going to look the same for different types. For instance, if we defined a function minimum value whose sole purpose was to return a copy of the minimum value between two parameters, the definition of that function, kind of irrespective of the types, could be as follows. If B is greater than A, return A, otherwise return B. And this would hold whether the types of A and B were, say, doubles or characters or integers, strings, as long as the greater than operation was defined, and pretty much any of our user defined types, as long as the greater than operator was defined for two arguments of the type under comparison. So the question becomes, could we, create a template or a blueprint from which these functions here could be constructed so that we're not like, copying and pasting. For instance, we might define minimum value for two doubles once, and then, I don't know, you need one for two integers, so you just copy and paste it, change up the types of the parameters and return types, and hey, you have an integer version. Then, okay, now I've found out I need a double version, so I'm going to do the same process, copy and paste, change the parameters to characters, as well as the return type. And if you notice here, like the implementation hasn't changed. What's problematic in this case are the types of the parameters. So the question becomes, could we like somehow leave open the type and then have the system somehow generate these definitions for us such that we don't have to perform this copying and pasting and changes ourselves? So the question becomes, could we say like minimum value is going to be defined for two parameters of type T, and the return value will be type T. And then the implementation, irrespective of what T is, as long as T supports the operator greater than, this code, we should be able to derive a definition of this function for that code. For instance, if we wanted to compute the minimum value of these two characters, is there a way that by invoking, say, minimum value with two characters, this code over here could be generated for us? Or the case with two integers, if we were to invoke minimum value 7, 1, so two integer values, is there a way to get this sort of code generated for us from the template? And then likewise, just I guess to be kind of complete here with the last one, what if we have two doubles? Is there a way to generate the minimum value code from that template? And if you think about this, like we've all seen templates, somewhere kind of, maybe you've seen a web template or I don't know, but something where you're given, I don't know, maybe some text or something that has some placeholders, like this function here, T could be a placeholder. And then when you're ready to use it, you go ahead and fill out what kind of T should be. In the copy and paste process, we were doing just that. You could think about our initial copy and paste and then change as a template of sorts. We were using this minimum value function whose parameters and return types were doubles. We went ahead and copy and pasted that, and our find and replace on the copy and paste was changing the doubles to characters, from the green to the blue, or from the double version to the integer version, changing the double to the int. So if you start thinking about that, the process here would be no different. Maybe if we had, this out in a text file somewhere, we could do a copy, or even, I guess, a find and replace, change all occurrences of T to the type that I'd like to generate a definition for, and then copy and paste that into my code. But again, we want to try and avoid us having to go through that process. So is there a way that we could give this template to the compiler, and then when it sees these calls, it could go ahead and create the code for us? Well, we're going to have that capability through function templates. So in C++, function templates are going to allow us to define or allow generic behavior to be encapsulated inside a function and then called for different types. What do I mean by the generic behavior? Well, if we look up here, this minimum value, the definition of what it means for one of two values to be considered a minimum value is generic across all of these types. The definition isn't changing. The only thing that we're seeing change in our definition of minimum value was the types of objects under evaluation. So the representation of such functions is almost identical to the functions that we've talked about to this point, with the exception that the types of the parameters are going to be left open as template parameters. So we'll have kind of that placeholder text there. Conventionally, it'll be T. And then when that template is instantiated into a concrete definition, those kind of placeholders get replaced with the concrete types for which we're deriving the definition for. And the compiler will essentially generate code from our function template by replacing the template parameters by their concrete types. So here's our first function template in C++. The first thing we have to do is tell the compiler, hey, what you're about to see next is a template. It's kind of an abstract definition from which you will need to define a concrete definition from. So to do this, you go template type name T. So here we'll get into this in the next set of slides, but here you're essentially saying T is going to be a placeholder for a type name. And then we just go ahead and use T anywhere within the return type, the function signature, or the body of our function definition. And the cool thing about this will be when we instantiate, say, a version of this code that would operate on 2 characters, it's going to go through and replace. So if you look here, minimum value of A and B, it will know in that case, and we'll get into how the compiler deduces the type, but it'll know that the return type should be character, that the 2 parameters here are also going to be characters. And again, it's all the compiler's kind of going to do here is generate this code by doing a find and replace on T. It'll take the template, drop it somewhere and go, okay, they wanted a version of this for characters. Let's give them a version for characters. Replace all instance of T with character. And now you have a minimum value that will operate on characters. And likewise would happen to integers and doubles. And it's not going to do this kind of multiple times. It will do this once. So if it already hasn't generated a character version, it will generate it. If it has, it'll use the existing definition that it had already produced. So with that in mind, let's move into, I guess, function templates in a little bit more detail than what we covered here. So see you in a little bit.